Hello and welcome back, guys. So in this video I'll tell you why do we do VLSM. Okay, I think the recording is working. Why? Number one, how? let's say you have a network over here with something like this, right? So you have a LAN over here, you have a LAN over here, right? You have 10 hosts over here, 30 hosts over here. So what would you do? Like how would you purchase a public IP, or like how would you assign a IP to these things, right? So even though if you don't have a public IP, so you might just be using 192.168.10.0, right? So you might be normally using this kind of IPs in your home, in whatever environment, right? Let's just suppose this is a home environment kind of thing. So 10 hosts, that means, so suppose if you are using this IP for this network, how many hosts can you have? 256, right, in total. How is because in class C what happens is that 192.168.10.0, right, 255.255.255.0. so you can't be touching all these 3 octets in class 3. Only the last octet could be used for hosts, right? And then how many hosts can you have is basically how many hosts can you have is basically you have 8 bits, and then after that how many can you turn it on. So if you even turn on everything, 1 2 3 4 5 6 7 8, so you will only have 256 hosts, right? That you can use with this ID or class C kind of IP. Okay, so in such cases what do we do? So now we have used the whole network of, like, we have not used the whole network, but what has happened, so suppose you have 10 hosts, that means you might be using .1, .2 all the way to .10. Now what? So .11 to .256, it's wasted, right? You are not using it. So in VLSM what we do, basically we customize the class as per our need. Okay, so we basically customize the slash or CIDR value as per our need. So how do we do that? Is basically, first of all, we find out how many hosts we have, and then based on that we customize it. Okay, let's have a quick look. So I will have to generate a new subnet for that. So for 10 hosts, I'm doing it for the first requirement over here. Subnet will be 255.255.255. And then number of network will be 2 to the power n, which is basically the on bits, right? In class C all this will not be counted, only the ones at the last octet which are on will be counted. Okay, and we can have number of network 2 to the power n minus 2. So I mean not number of networks, sorry about that. Let's just erase this thing. It's number of hosts. How many number of hosts do we need? 10, right? So if we need 10 hosts, how much should be our number? So why am I doing minus 2? Is because one is for network ID, the other thing will be used for broadcast, right? I will make a table and show it to you, don't worry. You just don't have to worry about it. So first last IP, then you have your broadcast, you have your subnet, or you can even say network ID, NID 192.168.10.0. 0. And another thing that we need to also find out is block size. So these are the 4 things that we need to first of all find out. So if we need 4 hosts, what do we need to do? 168 dot or what I can say is how many hosts or how many off-bit do you need to actually have that number of hosts. Okay, so let's have a look. So 2 to the power n minus 2, we need 10. So 2 to the power 1 minus 2, it's not really helpful, right? 2 to the power 2 minus 2, 4 minus 2 will be 2, right? That's not helpful. 2 to the power 3 minus 2, 8 minus 2, 6. That's not helpful. So 2 to the power 4 is 16, right? 16 minus 2, 14, right? So 14. So we can't really have exact 10 hosts because of this 2 to the power n requirement. Okay, so in binary conversion you want basically have exact numbers. Okay, so of course you might be saying like even in VLSM 4 of it is basically unused. Okay, 4 of it will not be used because our requirement is only for 10 hosts, right? So in such cases what do we do after that? So we know our requirement is 4. So if you see over here n, so number of off bit that we need is 4, right? So the first 4 bit will be on bit and then the last 4 bit will be off bit, right? So 255 dot, so what will be our subnet then? 255 dot, so this is 128 64, we know that 128 64 32 16 8 4 2 1, right? So if you add this thing up, so first will be 128, second will be 64, third will be 32, and then 16. So if you add this up, so if you add this 2 together, you will have 192. If you add this and this 2 together, you will have 224, and if you add this together, you will have 240. So our subnet is 240. What is our number of network? Number of network is the number of on bit is basically 4, right? 2 to the power 4. So these are the number of networks that you can have. Imagine how many network you will have. So 2 to the power 3, 16 networks is what you will have. So block size is nothing else but 256 minus 240, which is 16, right? So this is also called a jumping value as well. So you will have 16 jumping size, and then what will happen is, so it will be dot 16. This is the jumping value that we need. Okay, so similarly it will be dot 32 all the way. You can also check this thing. Okay, so a valid thing that will happen is 1 2 3, right? So if I go all the way down, I think it will be 48 and then 64 4 5 6, let's go down 80, right? Let me bring up my calculator as well so that I don't make a mistake. It will be 96, of course. 96, 7 will be 96 plus, what's the jumping value? 16, right? 112. 8 will be plus 16, 128. Similarly, all the way you will reach until 16 number of networks, and you will reach 256, but this won't happen because you won't have 256. Okay, but the number of networks that you will have is basically 16. Okay, so you can even validate it. So these are the number of networks. So this is this itself is one network, this itself is another network. Okay, so this is the first block. So in one block what will happen, we'll have 14 hosts, so which will be basically 192.168.10.1 all the way up to, so you can even write the broadcast from over here. So you know the jumping value is 0 to 16, right? So what would be the last value? 168.10.15, right? This will be your broadcast, and then again the last IP will be .14. Okay, 10.168.192. so your number of hosts, the value over here, and the number of valid IPs should be same always, otherwise your calculation is wrong. Okay, so similarly in this case what will happen, we'll have 17 all the way up to 30. Okay, dot 30, 10.30, and over here you will have 31 and then 32. 32 will be your network ID, and then again all the way up to over here, and then dot 47 will be your broadcast dot again over here. Okay, so similarly all this way you will reach over here until the end, where what will happen, you will have 192.168.10.255. that will be your last. Okay, so because after this what will happen, your whole thing changes. Okay, because that's the number of networks that you can possibly have. Okay, after this what happens, 192.168.11.0, that's like completely different prefix in itself, right? So since we have used until over here, so our first requirement is met, because we have like 14 valid hosts over here, 14 hosts, and our requirement is only 10, but 4 is extra, right? Don't worry about that. Now when we are doing VLSM, what do we do? When we create our next thingy, we will be using 192.168.10.16. okay, so now we will be using the IP from with .16. okay, so let's make this slash whatever we want. So what's our requirement? Not whatever we want, but as per our requirement. Our requirement is 30 hosts, right? 30 hosts. So in order to have 30 hosts, what do we need to do? I'll teach you. 255.255. So since this is class C, the 3 octets can't be touched. Only the last octet will be thingy. The last octet will be open for hosts, right? So why do we have 255 over here? Because it's 8 of them. Okay, so just count it yourself, 8 of them. So you can't, so all bits are on over here in class C. Similarly in class B, what happens? So you will have /16 is the default CIDR, which means the first octet and the second octet is thingy, and then the second last and last octet can be modified for hosts. Okay, so in this case what has happened, all we need is 32 hosts, right? So 2 to the power n minus 2, how many do we need? 2 to the power n minus 2, imagine 2 to the power 3, 2 to the power 4 is 16, 2 to the power 5 is 32, minus 2 is that, right? So number of host that we need is basically 30, right? And how many is that? 2 to the power 5 minus 2, right? Number of hosts equals to 2 to the power n minus 2 equals to 2 to the power 5 minus 2. We will get 32 minus 2, exactly 30, right? So number of bit is 5, right? In this octet. Okay, in this octet how many bit will be there? 5 of them. So that means 3 will be on, 5 of them will be off. Okay, 5, 6, 7, 8. Yeah, that means our subnet will be 255.255.255. What will happen? The first is 1 into 2 to the power 7 plus 1 into 2 to the power 6 plus 1 into 2 to the power 5. That means 128 plus 64 plus 32, which will be 192 plus 32 will be 224. So our subnet will be 224. Similarly, what will happen? What will be our number of networks? Is basically nothing else but, so see, in this case we skip everything before it. Since this is class C, right? So we can't be touching the first 3 octets, only the last octet will be looked at. And then in that case, how many bits are on for network? Is 3, right? 2 to the power 3. So this 3 is like the square root. Okay, I mean like it's to the power n. Okay, so number of networks that we'll have is 8. And another thing that we also need is block size or jumping value. We can also say block size, jumping value. Jumping value will be 256 minus 224, which will be 32, I guess. Yeah, so let's make our table again. ID, first IP, and then last IP, and then we will also have our broadcast over here, right? The first IP is 192.168.10.16 because if you see over here, we have already used it until 16, so we have a valid IP of 10.1 to 10.14. 15 is our broadcast, so we can use the IP, this network, right? So since this network is already being used by this LAN is using that network. For this one, each, see this one number, this is one network, this is two network. So since this network is already occupied, can we use that? No, right? We have to use the other one. Okay, so if you're making your table, what you can also do is just do dash 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 dash, and then just come directly to whatever is next available or whatever has not been used, whichever network has not been used. Okay, so I'll come over here 10.16. okay, so what's our jumping size? Jumping size is 32. That means 48 plus 32 will be 80, and then again 32. So even though there is all these values over here, I'm just counting it from here. Okay, 3 4 5 6 80 plus 32, 112 plus 32 dot 144 dot 32, 176, and then 7 8. Okay, okay, so similarly it will just go on and on. Okay, so after this again 32, what will happen? Will you have 272? No, you won't have 272. You will have basically you will have 192.168.11 dot, what you will have is the last value will be 256, and then so that means 240 or you will have till 16 over here. That would be your ID. Okay, so similarly over here what we'll have, dot 255 will be our last broadcast IP, 192.168.10.255. okay, 254 will be your last valid host, 241 will be your thingy, and then you can also check your calculations. 241 and then 254, that means how many do you have? 1 all the way to 10 and then 14, right? Number of hosts that you should have is why did I make a mistake? Why did I make a mistake? Let's see. No, it's not until over here. It's thingy. I have to change few things over here as well, right? So it will be 11 dot, no, it will be 10.255. but why is it not making any sense right now? Let's see. 241 plus or 254 minus should be 10.15. okay, no, I mean 11.15. 11.15 will be your last broadcast ID, and then in this case what will happen, dot 14 will be your last. Okay, so what will happen, 241 to 256 will be your 16 of them, not 16, I think 15. 256 minus 241, why am I adding it up, 241, 15, and then plus 14. So you will basically have 30 hosts. Okay, 30 hosts over there. Similarly in this case as well, what will happen, so if you see dot 17 and then dot 47, the broadcast does not always have to be 255. Okay, it can be different whenever you're doing VLSM though. 46, so that means 17 to 46, right? You will have 30 valid IPs over here, because that's how we have made it, right? So this is how you can compare your thing as well. So this network should satisfy our requirement, right? So the next, suppose you add another network. Suppose you add something else to your network. Where is our network? So here, so suppose you add another network with, let's say, 30 hosts. After that, what you can do is, so since a dot 0 is already occupied, right? The first one was already occupied, right? 0 to 16 was already occupied. So 0 network was occupied. 16 is now used for this. So if you have to use another network for different other hosts that are joining in, you could use this block 192.168.10.48. You could use this block to give them different hosts, valid IPs, everything. Okay, broadcast ID, everything. So what has happened, so since this is also not really like perfect, exactly perfect, because see over here it's perfect, the number of hosts and requirement is same, right? In this case what has happened, it's a bit more, right? The number of hosts should be more, it should not be less. A bit more does not matter. 2 to the power cube minus 2 would have been only how many? 8 minus 2, 6. So what, only 6 of them would be using, whereas our 4 other staff might not use in that particular department. This could be HR, right? This could be sales. So what you will just say, like, people, oh, okay, only 6 people in your department can use internet. That's not possible, right? So as a IT person, we need to think about it as well. That's why a bit of extra is not, or it's all right, okay, but it's still efficient. It's not efficient enough, but still it does the job. Okay, it's efficient than this one, like it's efficient rather than to use the whole thing 168.11.0, right? So it's rather than to, so if you are not doing VLSM, you might just be doing 168.11.0. so you will have like 256 hosts over here, and then there is like so many of them that you are not using it, like 244 of them you are not using it. Even over here as well, you have so many left out, right? So even though it's not just, even though this is very bad, this is comparatively less bad. That's the only difference between them. Okay, so it's just very bad versus bad only. You know, the amount of badness is less in this thing. So similarly, since we have already done this, so we can also do a classless in other things. So for the same requirement, I could be using something else. All right, I'll show it to you. This is our router, and then you have our LAN. We have our LAN, right? So 30 and 10 hosts, right? So you might be thinking, why use class C? Why, if you can customize the number of hosts, why not class A? You could do that, does not matter. So let's take IP like 10.10.10.0. Okay, let's take this IP and let's make it, let's suit it as per this requirement over here. Okay, so first thing first, let's see. So for, I'll not do the less host, first of all, always whenever you are making or doing a VLSM, always do for the higher one, okay, for 30 hosts. That's always a good practice for 30 hosts. So first thing that we need is subnet. So what will be our subnet? Remember, in class A, what happens? You will have 4 octets. Only the first octet is fixed for network, otherwise it's fixed. Everything else is for the host, right? So 3 octet is for the host, first octet is for the network. Right, so subnet will be 255.0.0.0. This is how it is, or it should basically look like, right? But what happens, we are making a classless, right? So how many hosts do we need? Again, same thing over here. 2 will be number of hosts that we need is 2 to the power n minus 2. So that means 2 to the power 5 minus 2 equals to 2 will be 30, or 32 minus 2 should be 30. The number of hosts that we need is 30. So what should happen? Only how many bits should be off bit? Only 5 bit, right? So in this case, what we can do is 255. We can't really touch anything in this, in the first octet, because this is class A. After that, what will happen? Do we how many off bit do we need? Only 5, right? So in this second octet, how many bits we'll have? 8 bits. 8 bits it's on. And then again in third, 3 4 5 6 7 8. Why am I doing 1 on 1? Because we just don't need that many hosts, okay? That's why we are turning every bit on, okay? And then over here again, what do we need? Only 1 2 3, and then 0 0 0 3 4 5 6 7 8. Okay, so 255.255.255 dot, what will happen? What will be our subnet over here? One 28 plus 64 plus 32, right? 224. Looks same, and doesn't it? See over here, 224. But there will be something different. What will happen is, number of networks, it will be massive. You know why? Because what will happen? 2 to the power 11. You know why I did 11? Because see, this is network part. Can we touch it? No, right? So since these are the host section, and among that host section as well, how many bits are turned on is basically 8 over here, 8 over here, and then 3 over here. That means 8 plus 8 16, and then 17 18 19, right? So I made a mistake over here, 19. So imagine how many networks are there. So many, right? The host is only 30. So where will you use it, right? So it's like, even though you have small chunks, but your network will be like 2 to the power 19 is like, how much is it? 2 to the power 19, that's like 500,000, 24,000, 500,000, 24,000, 288. Look at the sheer number of networks, right? So it's very much. So imagine, like, whenever you're making your networks, you're like, the number of networks will be so many, right? So if you are making your table again, what you do, block size, you will have 256 minus 240. Again, you have a block size of 16, right? What will happen over here? Network ID first IP. I think I should use a ruler. Oh shit, and not shapes. There is no ruler. Yeah, I could just use a line. Alright, okay. Much better. Better than my crooked line, right? Let's just get rid of this thing. Again, let's insert a shape, which is our line, right? Same thing again. Another line. Same thing again over here, just to make it tidy, okay? Even though it's tidy, my handwriting is shit, right? IP, last IP, and then you have your broadcast. So imagine 10 dot. So what's the IP that we are currently looking at? 10, right? So what will happen? 10 dot 10 dot 10 dot 0 is our first network, right? And our first IP will be dot 1, and then what's our jumping size? Dot 16, right? 10 10 10 2, right? And then this will be 14.15. This will be our broadcast. So we will be using this particular address, and after that what we will do is we can use this particular block. This block is already being used. Again we need to do a VLSM for the other one. Okay, so since this block is used, so for the other 10 hosts, what we can do, we can use this particular network ID from here. Okay, from here we can use it for that. Okay, so let's have a look at it as well. So what would be a subnet? What would be a subnet is 255.255. I won't be explaining that because so since this is already thingy, 255 is already there, so you have like all the bits on over here, all the bits on over here as well. You can't be touching the first bit because we are using class A ID. And then after that, how many hosts do we need? Only 10 hosts, right? So that means how much should it be? 2 to the power n minus 2. So 2 to the power 3 minus 2, is that possible? No, right? 2 to the power 4 minus 2, yes, we will have 4, right? So that means how many bits should be on bit, off bit? 4, right? So that means 1 2 3 4 should be on bit, 4 of them should be off bit. So that means 4 bit on means what would be our subnet? 192, and then after that 224, and then 240, right? That would be our subnet. What would be our number of hosts? Of course it will be 2 to the power n minus 2, which is 2 to the power 4 minus 2, which is basically 14, right? Jumping value,
next valid network ID would be 10.32. How many number of networks we will have? So many, right? Number of networks 2 to the power n. How many are there on bit? So since it is class A, that means this is already reserved for network, and then this is reserved for host, and within that host as well, what we are doing, we are only using only the 5-bit, right, from the last octet. That means how many bit is on? 16 and then 4, 2 to the power 20. You can imagine the sheer number of networks that we will have, right? So first IP will be .17, the last IP I mean, then you'll have a broadcast which will be 31, this before it, this will be 30, and the number of hosts that we should have is basically 14. Okay, so if you calculate over here, 17, 18, 19, 20, right? 17, 18, 19, 20. 4 of them over there, and then 10 over here, 22, 30, right? So 14. That means our calculation is correct. Okay, so we will be using this particular ID. So imagine, like, again, this 32 is free for another host if it is connected to our network, right? Or I mean, if it is connected to our router. So you can basically divide a particular IP into different slash value just to customize it as per your need. So as I've said, this is not the perfect thing, but still it's a comparison between, or it's a choice between very bad and less bad, okay, or just bad only. Alright, so that's it for today. If you have any confusions, please do let me know. I will definitely answer it for you, and then you will be smiling. See you in the next one. Take care.